Hi, welcome back. This is now the last video for unit number 2. This is still on the rational exponents, but specifically, the target of this video is to discuss or demonstrate practice exercise C of lesson number 3 for exponential equations. Again, I would like to repeat as a disclaimer, the exponential equations here are just the basic forms of exponential equations. If there are some exponential equations that will not be covered by this video and the previous videos and in our modules, it will be left for the next level higher mathematics. I'm sharing to you right now, again, the material, our module already opened in the Kotobee Reader application software. So we have here our lesson 3, exponential equations. For the previous two videos, we already started simplifying or solving the exponential equations. When we solve exponential equations, the main target is to solve for the value of the variable which can make the equation true. Similar to this one, we have practice exercise C. Our goal is to come up with a value of the variable when substituted to the equation will make the equation true or equal. Let us use this practice exercise, and I have placed them already in the Paint application software for us to be prepared with all of our doodles and scribbles. As for number 1, we have here the difference of practice exercise 3 C from practice exercise B and A is that for practice exercise C we have multiple variable presence of variables. We still have the same variable. We are using the same variable x, but there are more than one variable x here, right? So in this case, we are going to apply very important laws of exponents and other important processes for us to simplify them. So let's start with number 1. Number 1 is actually 8 to the power of x minus 1 is equal to 4 to the power of x. No worries about the presence of variables on both sides. What you need to worry first is to express both sides, both bases of the exponentiation found in both sides of the equation with same base. 8 cannot be expressed as base 4. 4 cannot be expressed as base 8. But both of them can be expressed as base 2. So let us try. 8 is actually 2 cubed. 4 is actually 2 squared. So we have expressed them with base 2. But do not forget the additional exponents placed in each side of the equation. So that's multiplication. Now we apply here the power rule. So you have 2 to the power of 3 times x minus 1. Take note that the x minus 1 is grouped and it's not just 3x and then minus 1. 3 times the group of x minus 1. Why? Because the x minus 1 here is the exponent of 8. And when we express it as 2 cubed, x minus 1 is still an exponent of 8. So when we try to multiply using the power rule, we need to multiply 3 to the binomial x minus 1. That's why we have group here. So the other side, you have 2 to the power of 2x. So again, multiply the left-hand side to both, not just to the one term. So you have 2 to the power of 3x minus 3 is equal to 2 to the power of 2x. We need to stop at a point. We need to stop using the not need. We may stop using the loss of exponents at a point wherein we cannot combine any more exponents and we have the same basis already. Because from here, we already have same base 2. We can now use the property of equivalent exponents and equate the exponents 3x minus 3 equals 2x. Now, again, instead of exponential equation right now, the form that we have made is already a linear equation. So how do we solve this? Subtract both sides by 2x. So that's why 3x minus 2x becomes x. 2x minus 2x becomes 0. And then add both sides by 3. You have here plus 3 and plus 3 on the other side. That's why you have the answer x is equal to positive 3. Hey, I'm just it automatically writing the answer because I'm hoping that you could follow already the steps. Or if you can't, so let's do it step by step. 3x minus 2x minus 3 is equal to 2x my minus minus 2x. So this will become x minus 3 equals 0. Then x minus 3, sorry, x minus 3 plus 3 is equal to 0 plus 3. So that will be removed. So x is equal to 3. Yeah. So x is equal to 3. Let's try to check whether our answer is correct or not. 3 here. 3 minus 1 is 2. So what is 8 squared? 8 squared is 64. Use the same value for x on the right hand side of the equation. 4 cubed is also 64. This proves that this is really the correct solution for number 1. Okay. As for number 2, okay, let us copy them here. 9 to the power of x, 27 to the power of x is equal to 243. Right. We can express all of the bases here by base 3 because 9 is 3 squared, 27 is 3 cubed, and 243 is actually 3 to the power of 5. Let us check. 3 times 3 is 9. 3 times 3 is 9, times 3 is 27, times 3 is 81, and times 3 is 243. In short, 243 can be written as a 3 to the base 5. I mean 3 to the exponent 5. So we could express 9 as 3 squared to the power of x. And then 27 as 3 cubed to the power of x equal to 3 to the power of 5. Now, before we use the property of equivalent exponents, let us exhaust all power laws of exponents. Number one, power rule. So 3 to the power of 2x and 3 to the power of 3x is equal to 3 to the power of 5. Another law of exponent to be applied here is the multiplication law, wherein we have the same base and we add the exponents. 2x plus 3x equals 3 to the power of 5. Now that we have here, we have already one base here and one base, then they have the same bases. We can equate the exponents. 2x plus 3x equals 5. We can add them because it's already a linear equation. 5x equals 5. Divide both sides by 5. Divide both sides by 5. So you have here x is equal to 1. Checking. Let's try to check. 9 to the power of 1 is 9. 27 to the power, let's just green kasi checking to eh. 9 to the power of 1 is 9. 27 to the power of 1 is 27. 9 times 27, is it 243? Right. So 9 times 27, you may use your calculators there. 9 times 27, the answer is still 243. That's checked. Therefore, this is our solution. Okay. So the difference for number between number two and number one is in number two. In number one, we just simply express both sides by same basis, and then we apply the necessary loss of exponents. In number two, same thing. We express both sides with a similar basis, and then we apply and exhaust all loss of exponents. How about number three? Okay, I will add additional space because I believe number three will need much space. Okay, this is number three. Number three is 16 raised to x over 2 power of 3x is equal to 4 to the power of that's power x plus 1. And let's try to express all by base 2 because this is the smallest base here. 16, as we all know, Okay. 16 is 2 times 2, 4 times 2, 8 times 2, 16. So 16 can be written as 2 to the power of 4, still raised to the power of x. The denominator is already in base 2, so no need. And the equals the right hand side is 2 squared, that's 4, raised to the power of x plus 1. Okay, so here, let's exhaust muna all loss of exponents. So that's 2 to the power of 4x over 2 to the power of 3x. Here on the other side, again, don't forget to multiply to all. So you have 2 to the power of 2x plus 2. Your left-hand side may use or will use the division law. So this would become 2 to the power of 4x minus 3x is equal to is equal to 2 to the power of 2x plus 2. And then we have same basis already. So we could have the expression 4x minus 3x is simply x is equal to 2x plus 2. Okay? I already subtracted 3x from 4x. Then we subtract both sides by x, 2x. X minus 2x is equal to this here. 2x minus 2x plus 2. So you have negative x is equal to 2. Divide both sides by negative. So x is actually negative 2. Okay? So checking. Let's check. 16 to the power of negative 2. I will show you the checking so that you will be guided. I will just simply need to add more spaces here. Okay. Pardon. I was not expecting that the space is not enough. Okay. So the given is 16 to the power of x. So we will have here 16 to the power of negative 2 over 2 to the power of 3 times negative 2 is equal to 4 to the power of, this is the given, negative 2 plus 1. Simplify both sides. So this could be rewritten as 16 to the power of negative 2 muna over 2 to the power of negative 6 is equal to 4 to the power of negative 1. So we have it here. We can put 16 on the denominator, 16 squared, and you have here 2 to the power of 6 is equal to 1 fourth. What is 2 to the power of 6? Right? 2 to the power of 6 is 64 over 16 squared, which is actually 256, 1 fourth. Now, 64 divided by 256, you may try using your calculators, right? Is actually just equal to 1 fourth equal to 1 fourth. This proves that our answer is really negative 2. If you don't want to reach here, simply use the loss of exponents here. We know that it is actually 2 to the power of 6, and 16 is 2 to the power of 4 times 2. Dapat 1 fourth. Okay? There's also another way to check this one. Let me write it here. So this is 2 to the power of 6 over 2 to the power of 8, and 1 fourth sa kabila. So this is actually 2 to the power of, using the division law, 2 to the power of 6 minus 8, which is 2 to the power of negative 2. Bring it down, 1 over 2 squared, and finally 1 fourth, which is actually the same as the right hand side. So you can exhaust any other forms of checking as long as you will reach the correct answer. So whatever your answer is here, here and here, if it will not make the equation true, then definitely you did incorrect steps. You do it again all over again. Mind you guys, mathematics needs step by step. So do not be, what do you call that? the feeling of not be disappointed, dismayed if in case nga you were not able to answer the problems. You just simply need to do it again. Take your own time. If you were actually confusing in confusion already, stop, take a break, relax, and return to it as soon as you are you are already okay. So this video is the last for unit number 2. We may have a quiz later on covering all unit 2, all the topics, all the lessons of unit 2. So you may use this video including the previous videos as your review. So the next time that the videos will be available, it will be on unit number 3 soon. That's all. Use this video, practice, enjoy. I mean, really enjoy. Goodbye.